when we talk about the equilibrium in financial markets, we make that we compare between money and bonds, and how money is a liquid asset and bonds is an interest-bearing asset. And we discussed the demand for money and what the reasons we demand money, etc. So one thing I want to highlight, sorry, that's supposed to, is the demand for money. So when we talk about demand for money, we talk about three reasons why we demand money. First, transaction demand. Second, precautionary reasons, and also speculative demand. And we made this distinction between the first one and the other two. So the first one depends on income mainly. So higher income means higher demand for money for transactions. So I'm talking about the first component, or the first factor that determine demand for money. And the other two factors here, they depend on the interest rate. And this, so precautionary demand and speculative demand for money, these two depends on the interest rate, and the relationship here is negative. So between the interest rate and demand for money for these reasons. So again, just to sum up what I said here is the idea that the demand for money is determined by three factors: transaction, precautionary, and speculative demand. The first one, the transaction demand, depends on income level, and we use nominal income as a measure of transactions, or the level of transactions in any economy. And then the other two, which is positively related to money demand. So the more transactions we have, the higher the demand for money for transaction. And the second point is that the precautionary demand and the speculative demand for money, basically they depend on the interest rate, and the relationship is negative. So they are negatively related. So higher interest rate means, again, less demand for money because of these reasons. And we explained that when we said about how the money, it's a very liquid asset, but it doesn't give positive return. So it's compared to bonds, for example. Bonds are interest-bearing assets. So basically, holding bonds will result in receiving some return, positive returns. So one more thing we talked about equilibrium. So in the money market, how equilibrium in the money market is determined. And when we talked about equilibrium, we said about how you think about money as like any good, where the equilibrium is determined by supply and demand. So if we know that demand depends on these three factors, and we know that if we're going to plot the demand curve, is going to be a downward sloping demand curve on this space here, when we have the interest rate on the vertical axis and money on the horizontal axis. So this is the sort of how the demand curve or demand for money would look like. And we know now, because income level is not one of these two factors here, or not, is like a variable that is not on one of these two axes here. So any change, but still relevant to demand for money. So if it change, that means that will shift the whole demand curve either to the right or to the left, depending on the change in income. While changing interest rate mainly will mean that you move along this the same curve. So in terms of changing income, if income increased, that means the demand for money curve will shift to the right. If income or nominal income decreased, that means the demand for money curve will shift to the left. So this is the demand side. Again, just remind you what I said. We want to think of money like any other good, like in a market, that the equilibrium outcome depends on supply and demand. So we know what determines demand and how the demand for money curve will look like. Then we need to think about the other side of this coin, which is supply. So supply here is money is different goods, so basically supplied by or controlled by the monetary authorities or the central bank. So if we and that is the essence of monetary policy, is basically changing the money supply in a given economy. So for that's why we when we come to this point, we start talking about money equilibrium. We said, okay, supply, we will be treating supply as or money supply as exogenous. It's given by central banks, and it is independent of the interest rate, meaning it will be a vertical line on this space, IM space. So in that case, equilibrium in the money market will happen when money supply equal money demand and equal that given or that exogenous, variable here, which is the money supply, or what the central bank will decide for money supply. When we plot when we bring these two curves together, the money demand or the demand curve, which is downward sloping normal demand curve, like usual one, standard one, and the money supply, which is a vertical line, and we explain why we treat that as a vertical line. As we said in this graph, we just assume that, okay, money supply is given to us because it's determined outside this, is determined by the central bank. So we don't have to worry about it. It's just given to us. So we can't. So basically here, who would have the power to change this money supply? It's mainly the central bank could increase or decrease money supply depending on the situation in the economy. So if the economy is running too slow or entering a recession, and the central bank would like to stimulate the economy or push the economy out of recession, they will follow an expansionary monetary policy in which they will expand or increase money supply. Okay, and if on the other side, if the economy is running too fast or overheating because of there's so much demand compared to how much the economy can produce, then obviously that will translate into inflation or higher prices. And for central bank to control that or to cool down the economy or to slow the economy down and keep this inflation under control, so basically they would decrease money supply or follow a contractionary monetary policy, or basically just decreasing money supply or reducing money supply in this economy. So anyway, so the equilibrium point here is A. So, and that shows us money stock or M. And on the other side, we see the level of the interest rate or the equilibrium interest rate. We know already if if nominal income increase, that will shift the demand curve to the right, and that in this graph you'll see we'll move from point A to A prime, where we would have a higher level for the interest rate. On the other side, if we now talk about money supply, shifting the money supply curve or that vertical line, we would be basically referring to the actions by monetary authorities or the central bank when they change their monetary policy. So money supply here could be used as a monetary policy instrument where you actually change money supply depending on the situation in a given economy, as we explained in a few minutes later. So a shift in the money supply, a shift rightward or to the right, money supply curve, that means an expansionary monetary policy, and that will result in a lower level of interest rate. And the opposite will happen if there was a shift toward the left. That means the equilibrium interest rate will be higher. So the example on the screen now, what we see here, we see an example where we have an expansionary monetary policy because MS here, this curve, this vertical line here, shift to the left, meaning that the central bank decided to increase money supply, and how this, or what the implications of this to the interest rate, to the equilibrium interest rate, is basically lower interest rate. So we move from I to I prime, or the equilibrium point A to the equilibrium point A prime. So basically lower level for the interest rate. How does the central bank do that? Basically, they use the open market operation. So they go to the bond market to buy or sell bonds, depending on the situation, what they want to do, or what they want to achieve. So if we want an expansionary policy, if the economy is going too slow and we want to push the economy further, or support the economy, or push it back toward recovery, then we would need an expansionary monetary policy in which we want to increase money supply. And to do that, the central bank basically would enter the bond market to buy bonds. So buying bonds, when the central bank buys bonds, basically they're injecting the economy with more additional money. On the other side, if the economy, as we said, going too fast, and we want to try to decrease the aggregate demand, basically the central bank would follow a contractionary monetary policy in which they want to reduce the money supply, and in such case they enter the bond market to basically sell bonds. So basically they give bonds and just take money out of the economy, so reduce the money supply. Anyway, so this is basically everything I wanted to cover in this recap, which is related to the first question in the tutorial sheet. So if you look at the first question in the tutorial sheet, you will see that the first question is based on explaining the demand for money, or what are the factors. I'm just going to read that. So according to what you have learned in the lecture, what are the main incentives of holding part of your financial wealth in the form of money? So basically, we talk about the three factors that we already covered: transaction demand, precautionary demand, and speculative demand, and what determine each one of these factors. We talk about income, how nominal income is important, or we use it as a proxy for transaction, and this is positive related to demand for money. And then the other two basically depend on the interest rate and its inverse relationship, or negative relationship. So moving from here, if we now go to the next question on this tutorial sheet, let me just, we don't need this now. Don't need this now, or this. Okay. So in the next question, we have a money demand function, which looks like this. Let me just a second. Yeah, let me just write the money demand function. So the money demand function we have is MD over BT equal kappa OK Y to alpha, and R to beta. Okay, so there's you will see a subscript like this: BT, MDT, YT, RT. So I'm just not using the subscript just for simplicity, but there's a subscript there which just refer to time t. Okay, so in this in the first question, or what we need to do first, we need to of course we have more information in this question. Just let me put everything we have in the question first. So we know that this kappa is 0.6. We know that alpha is given 0.7. We also know that beta equal minus 0.3. Okay, so the first question, or point A in this question, I'm talking about question 2. Take the natural log of this money demand function to express it in the log form and then explain the economic meaning of these two coefficients, alpha and beta. So we want to, after taking the log, we want to explain these two coefficients. But before we do that, let's just remember some rules about using the log. So I'm sure many of you would remember these rules, but just to as a reminder, I would like to start with this part. So we know that if we take the we start with the let's say ln x over y, this will be ln x minus ln y. If we have let's say ln x y, that means we can this equal ln x plus ln y. If we have ln x to, let's say, to a constant, let's say a, so that means a times ln of x. Okay, so these are the sort of rules that we want to remember when we work through this question or this example. So what we need to do here, we need to take the log, the natural log of both sides. So basically we want to say the log of this md p over p equals the ln of all of this here, which is k, y, alpha, r. Okay, so we're just going to apply these rules here. So what we have here is, this is the first one. So this is the first rule here. Okay, so basically from here, that will be the ln of money demand minus ln of the price level equal, yeah. So for this one, we're going to apply the second one here. So basically these are multiplied. So we're going to have ln k or kappa plus ln y plus ln r. But then we also know that these are constant here, alpha, beta. So basically these could be, we could apply this rule here at the same time. So from this, we could say, okay, so that would be ln k plus ln, plus, we could just do it one step. We don't have to do two steps. So that alpha ln y plus beta ln r. And by the way, here just to MD is money demand. I'm sure all of you know that. P is the price level. K is just a constant again. So alpha, beta, these are coefficients or constants. Y here is real income. R here is the real interest rate. So in the lecture, I used the term I to denote the interest rate, and this is the nominal interest rate. But R here is just the real interest rate where you take inflation into account. So basically, it's real interest rate. So what we need to do here then, basically we could just get or express money demand on one side, just have money demand, and this will go to the other side. So basically that means we have here money MD equal K, so everything is the same, alpha ln Y plus beta ln R, and then plus ln B. Okay, so what we need to know here, or what we need to explain here, is the meaning of these two coefficients here, the alpha and beta. Just to do this, let me just highlight. So basically, so this is the first thing we were asked to do. We already done that. We express this in we express money demand in the log form, but we also need to explain what this alpha here means. So to explain that, let me remind you of something you already covered in your macroeconomic course, which is elasticity, and what elasticity means. So when we study elasticity, we basically when you did elasticity, let's call elasticity something like zeta, for example, equal or epsilon, call it whatever you want, equal the percent change in, let's say, in y over percent change in another variable, let's call it x. So the idea here is very simple then. So given this, we could actually think of, or this is basically, you could think of this as like ln, or the natural log of y in time t minus the natural log of y in time t minus 1 divided by the natural log of, again, similarly, xt minus the ln xt minus 1. So why I'm doing this exactly? Because this will be the same as if you give the derivative of this, the partial derivative of this y with respect to ln x. And again, how this is related to what we want to achieve here is basically, if I say from here, if I say, if I differentiate this with respect to y, then just think of everything else as constant, and there's no change in that constant. So basically, the outcome here will be, if I say then md with respect to ln y, this will be equal alpha. So similarly, if I do the same to with respect to r, to the real interest rate, that would give us, so let's say this is the derivative of this of money demand with respect to r, or the interest rate, that would be beta. So the idea here, we want to explain what this means and what this means. And it turns out that this is actually the elasticity. So what we have here, we can understand this beta, for example, as the interest rate elasticity of demand for money. Okay, so what that means, it means the percentage change in nominal demand for money given a 1% change in real interest rate. So in other words, if this R, or the real interest rate, is changed by 1%, okay, so how much money demand will change? It basically will change by beta, the value of beta. Oh, similarly, we could think of this alpha as the again, so the real income elasticity of the demand for money, which means this is the percent change in nominal demand for money given 1% change in this variable here, which is real income. So basically, that's very simple. That's how it is. Basically, we just looking at elasticities here. So the economic interpretation of these two coefficients, alpha and beta, so you're looking at elasticities, okay? And we will know what that means in, again, like we'll have another example on this in a second. So is that clear, guys? Do you have any questions? If you have any questions, please post your questions, or take the mic, or use the mic to say your question. So just feel free to interrupt me at any point. I hope that's clear. So just again, just before I move on to the next point, I just want to highlight that what we did here, or the first question, we had this, we were giving this demand, this function here, and basically we were asked to use or to take the natural log, or express money demand in terms of in the natural log. So we take natural log in both sides. And so we did this just following a few very basic rules about logs. And from here, we express this in this form here. So we have this is our money demand in the log form. And we were asked to explain, to give an explanation of alpha and beta. And all what I did here, just to show you why alpha and beta are just elasticities. So even if you didn't understand where that come from, or this differentiation here, or this, how did we do this? So basically, just in simple terms, what alpha is, what beta is. So basically these are elasticities. When we learn about elasticities in microeconomics, we basically, for any variable, so basically you say, okay, if X changed by 1%, how much the person change in Y? Okay, that would be the value of the elasticity. So in this example here, would be beta. Beta here is basically the elasticity for this one with respect to the real interest rate. So if the real interest rate increased by or changed by 1%, how much money demand would change by? So these are the percent change in money demand when the interest rate changed by 1%. Okay. Okay. Yeah, that's right. Okay. So Len here is the natural log. That's right. Okay. So how do we use this information now? So we know what R is, what alpha is, and what beta is. So in the second question, or in point B in this question, okay, so what we were giving here, we're giving some more information, and we were asked to use this information based on what we learned from step A. So it's according to your answer to part A, how much in percentage terms will nominal demand for money change if real income goes up by 5%? So what we have here, we have the question say, okay, if you know that there's a change, or the percent change in Y equal 5%, okay, how much the percent change in money demand would be? Okay, so this is basically what the elasticity means. Okay, so the idea here is that we already know that the elasticity is this alpha is, how much is it? I think we down a bit. Yeah, it's 0.7. So we know already that's 0.7. So that means the percent change in money demand will equal that change in real income, which is 5 multiplied by the value of alpha, or the elasticity, which is here is 0.7, which means the percent change in money demand should be 3.5%. Okay, so that's question B. Okay, just to be say, so this is point B, and here's point A. Okay, so we, in addition to that, in point C, we were asked to.
Why do you times by the 5, like 5 times 0.7?
Yeah, because 5 is how much is the change in real income is 5%. Okay, so just think about it. What alpha means? Let me just put that in other words, a different way. So what alpha means? It means if delta Y, or the percent change in Y, equal 1%. Okay, so that's basically money demand will change by the value of alpha, which is 0.7. Okay, so now actually the alpha, the Y here, or the real income, it didn't change by 1%, it changed 5 times that. Okay, so basically you multiply this alpha by 5, which is the change in the real income. Okay, so basically this is the how much real income has changed in percentage term, which is 5. So this was given in the question. Okay, I didn't share it, so I should have shared the questions as well, but I'm reading them as I'm going through the question. But I hope you have the chance to see the tutorial sheet on your screen. But in any case, I'm already reading the question. So the information that was given to us is, we have, this is what happened. we have a 5% change in real income, and we're asked to find out how much money demand will change by. But we already know that the elasticity is 0.7, and we know what the elasticity means. The elasticity means if real income changed by 1%, then money demand will change by 0.7. But what if I told you, no, actually it didn't change by 5%, actually changed by 5 times that. So basically all what you need to do is just to multiply 5 times 0.7, that will give us the percent change in demand for money. The following question, point C, we were given the same information, say, what if this change here in real income was accompanied by another or a 2% change in the real interest rate. So what we have here is that the R, or percent change in R, is 2%. Okay, so basically in that case, the percent change in money demand will equal this 2, then the change in the real income, times beta. Beta here is the elasticity here with respect to R, or the real interest rate. So that means it's time point minus 0.3, okay? Which means this should be point minus 0.6. Okay, so but this is the change that would happen only if there was a change to real interest rate. But in the question it asks us, what if in addition to this we had this as well? So basically we just want to work out the total effect. So the total effect here on money demand, or the percent change on money demand, would equal 3.5, which come from here, minus 0.6, which come because of this. That would give us 2.9%. So that's the total change, or the total effect on money demand. So hopefully this is clear now. But of course, if you have any questions, please let me know. So feel free to interrupt me at any point. So you don't have to wait until I ask you whether you have a question or not. Okay, so I'll just keep going, and you have, please, stop me at any point. So it's not a big deal. I'm just going to have a quick look at the chat. I'll see if there are questions I added answers. So I guess, yeah, it seems like, okay, no more new questions. So let me move to point D then. In point D, we have point D, we have the money supply. So in addition to what we already know about this function, we know that we were giving that money supply equal 6,000 pounds, and P, the price level, equal 20, and the real national income, which is Y, equal 1,000. Yeah, so we want to calculate R, the interest rate, the real interest rate. Okay, so that's not a problem because we have everything we need to calculate R. So if we look at equilibrium in the money market, equilibrium, we just said equilibrium happen like any other good when money supply, or when supply equal demand. So in this case, when money supply equal money demand. But what we have here is, just going back to the money demand function we have actually the real in real terms. So we have money demand divided by the prices, so which we can simply do here. We could actually divide both sides here by prices. So basically that means money supply over prices, or over P, equal money demand over P, which we already know the function, the money demand over P function, which is this one here. It's already given in the question. So we could use that, and we know everything here we know. So we know This kappa is 0.6. We know that alpha 0.7. We know y is giving now is 1,000. And we know that beta is minus 0.3. So the only unknown here would be just the real interest rate. So it's very straightforward to answer this question, but I'm going to do it with you now. So if you have any question, just let me know. So we already know. Okay, so we know that the this is the demand function, y to alpha and r to beta, and from here we could say, okay, so we want r in one side. So just think of that, you just want to divide by these two here, so just to get rid of them from this side. So what we would have on this side here, just only r, and that's equal. So just remember, we have money supply over P, but also we will divide by these two as well, which is the K and Y to alpha. So this is how it looks like. But also we want R, not R raised to beta or to any coefficient here. So basically what we're going to do here, so that's exactly the same as if you say this equal this one, money supply divided by P kappa Y alpha, but then this everything here is raised to the power of 1 over beta. Okay. So from here, we already know everything here about R. So we know everything, and I want you to help me to calculate this. So we have money supply equal 6,000. That was given in the question. And we know that this P equal 20. We know kappa equal 0.6. This K equal 0.6 times Y equal 1,000. We know again Y was giving to us 1,000, but it's traced to the power like the alpha, and that alpha equal, we know alpha, how much alpha is. So alpha here is 0.7, but the whole fraction here is raised to the power 1 over minus 0.3. So could you please help me now to calculate this and tell me how much R would be? See how fast you are using the calculator. Can anyone tell me, please, how much would that be? Yes, Sabina, that's right. So it's point, correct? So thank you. So that is 0.01 or 1%. Okay, so that the how much the interest rate or R would be. Okay, I hope this is clear now. Do you have any questions, guys? Any questions? Hopefully this is clear now. See how easy the idea is. It's just you just need to think of the equilibrium, and then given that we have all the information we need, we only have one equation with one unknown, then it is very straightforward to find out. Okay, so let me move to the last part of this question. In the last part of this question, it's very straightforward, I'll tell you why I'm saying it is very straightforward, because in the question, we said, okay, we were told that bonds are the only financial asset in the economy, and that the total nominal financial wealth is 10,000. So just think of, okay, if we have total wealth, let's call it Q, equal 10,000 pounds. And the question is, what would be the equilibrium nominal demand for bonds? So we want the demand for bonds. So these are bonds demand. So we want to find out that if the real interest rate was 2%. So R, if R was 2%, how much then the demand for bonds would be, of course, given all the information we know so far about the money demand. Okay, so does anyone have an idea about how to approach this question? Any suggestions, guys? Any suggestion? Any suggestion for this question, for this part? How would you calculate the, if your total wealth is 10,000, okay, and basically this will be, you know, between two things, okay? So basically this 2,000 or Q should equal, okay, how much you're going to spend on those or demand bond, plus the rest will be the money demand, okay, or that what you're gonna hold in terms of money. So from here, we could actually, we know that this be D equal Q minus money demand. So we know Q, but we can also calculate this money demand or this amount based on the information we already have so far from the question. So it's very straightforward, and that's why I said it's very straightforward, because let me just, of course, we know that an equilibrium money supply equal money demand. Sorry. Okay, so we know that from before, and that means we could, from here, we could actually say, okay, just remember, I just want you to remember the money demand function we had is MD over P equal this KY to alpha R to beta. Okay, so here I want money demand, so that means it's equal K Y alpha R beta. Of course, you multiply that by the price as well, PT. Why? Because this actually, this function here, if I want only MD, so you need to multiply that by the price or P. So that means P will come here. Okay. So anyway, so that's exactly what I did here. So in this case here, we know everything, or just giving this, we know everything we need. So basically, we know that this Keba is 0.6. This one is 0.6. We know that Y is 1,000 and alpha is 0.7. We know that R is giving to us is 2%, which means 0.02, and beta is minus 0.3 times, of course, times 20. Okay, so can anyone calculate that for us, please? Please do that for us. Just use your calculator and tell us how much that would be. Any suggestions, guys? Okay, so let me. Okay, I think some answers coming in the way. Yes, that is correct. So this, if you round it up, so this should be 4,885. Okay. Remember, we want here the bond or the demand for bond. So we know this now. So we know Q is given, the financial wealth is given. This now is this number here. So basically, what we need to do is just to calculate that, which is 10,000 minus the this one, which is 4,885, that would equal 5,115. Of course, these are pounds. Okay, and that would be the demand for bonds, and that would be that is the last point or the last question in this tutorial. Okay, I hope it's clear now. Just to summarize, what we did here is very straightforward. As I said, we were given the total financial wealth, and we were given the real interest rate. We wanted to calculate the demand for bonds, which is very straightforward because we have everything we need here. All information given, you just need to plug this money demand function just to replace this with the numbers, that information that were given to us, and then that and just calculate the demand for bond. So I'm going to stop the recording at this point. I'll take one or two questions, and then we conclude this before we conclude this session.